Now that you guys have a pretty solid foundation on finding probabilities, we get to introduce a higher level concept, and this is the idea of a probability distribution. And we'll be building on these probability distributions throughout the remainder of our class as we talk about a lot of the inferential statistics and things that we're going to be using. So first off, let's recall some terminology and solidify some terminology. A random variable is just an event of chance, that a variable that has a single outcome. So this is like rolling a die, drawing a card from a deck, right? Those are all random variables. Now, when we're talking about a random variable, we bring up these ideas of discrete and continuous random variables again. Remember back in the beginning lessons of this class, where we were classifying variables, we talked about quantitative variables that they could be labeled as either discrete or continuous. So random variables can be labeled in that way as well. A discrete random variable has a finite or countably infinite number of possible outcomes. Okay, so let's go here. So finite or countably, infinite number of outcomes. Okay. If you recall, continuous, on the other hand, means that the number of outcomes are not countable. All right. So an uncountable number of outcomes. All right, and so of these, the first type of random variable that we're going to focus on are the discrete random variables, and that'll be the focus of our lesson today, and then we'll build up to the continuous ones later, and we'll talk more about the normal distribution, which we've already introduced before, because that is used. So the normal distribution and our density curve are used to show a frequency distribution for continuous variables. Whereas for the discrete random variables, we just use a histogram to show that distribution, stuff like that. Okay, so the basics, the requirements for a probability distribution. A full probability distribution will have a list of all of the possible outcomes. Okay, and each of those outcomes will have a specific probability attached to it, a specific probability that that particular outcome happens. Now, note we're not necessarily talking about probability distributions where all the outcomes are equally likely. Okay, in this case, each outcome could have a different probability of occurring. The sum of all of those probabilities of all the possible outcomes will always be 1. You have a 100% chance of getting one of the possible outcomes, right? So let's experiment with this. Remember, the probabilities, a legal probability is always between 0 and 1. So keeping those two ideas in mind, let's look at some potential distributions. Let's see if these really represent a probability distribution. Look at this first one right here. Is that a valid probability distribution? Does it meet both of those requirements? Are all the outcomes listed? Do each of the outcomes have a valid probability attached to it? Is the sum of all those probabilities going to be 1? What do you think? Note, if you add up all of these probabilities here, you do get 1, right? But is it a valid probability distribution? Hopefully you're saying no, because of this probability or because of that number right there. Minus 0.5 is not a valid probability. Okay, so it does not meet our condition. That is not a case of a valid probability distribution. Okay, that one doesn't work. What about this second example here? So we have our outcomes listed, the valid probabilities for each of those outcomes, and what's the sum of all those probabilities? If we add all these up, yeah, we do get one. Boom, that one meets all of the conditions. So this is a good example of a valid probability distribution. All right, that making sense okay? All right, with that in mind, I'd like you guys to do this, go through that same exercise with these next two examples. These are just essentially relative frequency histograms, right? So we have the list of all the outcomes down on the x-axis. The height of each bar goes to the probability of that particular outcome happening. So you can find out all the different probabilities. So you can add them up, see if they equal 1, make sure all of the probabilities are valid probabilities, and tell me which of these are good. Okay, so not too bad. So pause while you do that, just the video, pause now. All right, now that you've identified those as a valid probability distribution or not, let's start working a little bit more with valid probability distribution. So we're going to take this probability distribution right here. 0, 1, and 2 are the possible outcomes. The probability of an outcome of 0 is 0.2. The probability of an outcome of 1 is 0.3, and of 2 is 0.5. So there you can find an average or expected value and a standard deviation for a probability distribution using these formulas. Now those formulas may look a little bit intimidating at first glance. So these next activities that we're going to do are going to walk you through doing these calculations by hand. Then I'll show you how to find them on the calculator. Okay, so essentially the mean formula, the interpretation of that is that you're going to take each outcome times its probability, and then you'll add all those up. This is a capital sigma in the Greek alphabet, that in front, right? And that just means the sum of. So the sum of all the x times all the outcomes times their probabilities, right? So similar thing on the sigma. So you're going to take each outcome and subtract the mean from it. Then that result, you'll square it. And then that result, you'll multiply by the probability of that outcome. And you basically do that calculation for all of the outcomes. And then add up all those results. There's our sum of. And do the square root of that. So a lot more tedious for the standard deviation part. But let's go ahead and do this. So we have this table that's going to kind of walk us through the step of finding the mean, finding the average first. So we'll do 0 times 0.2, we'll do 1 times 0.3, and 2 times 0.5. And that will give us 0. That'll give us 0.3. And then 2 times 0.5 gives us did you get it? Yeah, so we have 2 times 0.5 is a 1. Okay, so now with those we're gonna add up all of those values in this row. 0 plus 0.3 plus 1. And what does that give us? That gives us an average of 1.3. Notice that 1.3 isn't actually one of our possible outcomes. So the average of a probability distribution may fall in between possible outcomes. We also refer to this average as an expected value. So we expect to get between 1 and 2, right? Something like that. So our average for this probability distribution is 1.3. Well, what about for if we need to find the standard deviation? Well, we're going to take this 1.3 because that's part of this calculation. So we're going to do our outcome of 0 minus 1.3. Gives us a result of minus 1.3 for that one. 1 minus 1.3 gives us a minus 0.3. And then 2 minus 1.3 gives us a 0.7. Next part is to square all of those values. So 1.3 squared will give us 1.69. The minus 1.3 squared is 1.69. Remember, we're squaring a negative. It is going to be positive. So the minus 0.3 squared gives us 0.09. And then the 0.7 squared gives us 0.49. So the next step will be to take that column and multiply it by the probabilities, right? So 1.69 times 0.2 gives us 0.338. 0.09 times 0.3 gives us 0.027. And 0.49 times 0.5 will give us 0.245. Awesome. So next step, we add all of those up and then do the square root of that result, right? So 0.38 plus 0.027 plus 0.245 gives us, so the sum of all of these, hold on, let's draw that a little bit straighter, is 0.61. And so I'm going to find the square root of 0.61. And that gives me 0.781 as the standard deviation of this probability distribution. Now, that's pretty tedious. And no, we won't expect you to do it the long way using the formula by hand for all of these problems. However, we will expect you to at least be able to do it on your calculator. So let's back up a little bit. Go to your TI 83 or 84, and let's go to your stat edit screen. And in list 1, I want you to write the possible outcomes. Those are your X's, right? So 0, 1, and 2. And in list 2, you're going to write the probabilities attached to each of those outcomes. So 0.2, 0.3, and 0.5. So your list 1 and list 2 should look like mine right there on this calculator. So take a second, pause if you need to, get those in. Okay, once you have the entire probability distribution there in your calculator, now we can simply do one variable stats. So hit the stat button, go right to the calc menu. We're going to use one variable stats. However, in this case, that probability list it's a relative frequency list, right? That will be a second component. So in the past, in the other examples that we did in previous lessons, I told you to leave this frequency list blank, right? In this case, we need to put the list of probabilities in as the frequency list. And then we hit calculate, and boom, look at that. It gets us the average of 1.3 that we found before, and it gets us our standard deviation of 0.781 that we found before. But we didn't have to make all those tables and go through all those intermediary calculations, right? So a kind of a slick way to find a mean and standard deviation. Note the formulas work. We just showed that they do if you want to do it by hand, but it's going to be a little bit quicker if you're able to do that in your calculator. So just remember, the list of outcomes is your regular X list. and the list of probabilities then becomes your frequency list. Okay? You got it? All right. So given any probability distribution, you all should be able to enter in the list of outcomes and the list of probabilities and do one variable stats with list 1 and list 2. So note for TI-83 peoples, when you do the one variable stats option, this is what your command line looks like. Okay, it'll say one variable stats, and then you just do list 1 comma list 2 on the end. That second list that you put in, it'll automatically make that your frequency list. So you need to make sure you do both of those in there. Okay. All right. So moving on. On C here, it does walk you through putting those into your calculator and how to do this, and it even shows you what that command line looks like for TI-83 people. Now, if you're using the TI-84 with the updated operating system, you'll see the screen that I had that just asks for the X list and the frequency list, and you calculate it, and everything's good. You don't have to remember what goes where, really. Okay. Now, I told you that the average is also referred to as an expected value. Okay. So in that probability distribution we just did, we would expect to have a value of 1.3 as our result of this random variable that we're looking at. Okay. There are some other cases. So here's on number 6, finding an expected value. This is very appropriate when we're like assessing a game of chance. Okay. Go to a casino, whatever, you're playing a game with dice. So here's our situation with that game of dice. We say that if you roll let's see. So first, to play the game, it costs. And that'll be pretty standard, right? In this case, it's going to cost $2 to play this game. If you roll a 6, you win $7. If you roll a 3, you win $4. Otherwise, you don't win anything. So all of the other rolls don't get you anything back. Good. So let's fill in this table. First, let's make our list of possible outcomes. What are our possible outcomes for a die? Well, we could get a 1, 2, 3, 4, 5, or 6. Okay. So in our previous calculation, when we were finding the average of our probability distribution, our first list would have been those lists of possible outcomes. So when we're talking money, though, and we want to find the net winnings, the expected amount that we would win, then we're doing this average, but our first list is going to be the net winnings rather than the outcomes. So if we roll a 1 on our die, what are our net winnings? Well, we don't win anything from the game, but we did pay $2 to play. So our net is we lose $2. Okay. How about if we roll a 2 on the die? Same thing, right? We lose $2. If we roll a 4, we lose $2. If we roll a 5, we lose $2. What about if we roll a 3? If we roll a 3, we won 4, but we still paid 2. So what's our net winnings? We bank $2 then, right? Because we have the $4 winnings, we have to subtract what we paid to play. All right. What about for 6? What are our net winnings if we roll a 6? Well, we got $7, but again, we paid $2 to play, so our net is $5. And what's the probability of each of these outcomes? Well, we have a 1/6 probability for each of these, right? Because just a standard fair die is what we're using, so the probability of each of those rolls is 1 out of 6. Okay, so if we want to find the expected value, the net winnings for this game, let's go back to our calculator, go to your stat edit screen again. We're going to, so again, to clear we want to clear our list that we used before and put in our new ones. So go to list 1, hit the up arrow so it highlights the heading, and press the clear button. and enter, and it will clear that list. Same thing for list 2. Let's clear list 2. Okay, by the way, if you accidentally delete a list rather than clear, so if you went up to this heading and I hit the delete button, oh, list 2 went away. Oh, list 3 went away, right? That's no good. It's really easy to reset that. So just remember, don't hit delete. Always hit clear when you're trying to clear a list, okay? But if that happens, go back to your regular stat screen and just go down to number 5 and press enter on setup editor. Okay, now all your lists are there like they're supposed to be. All right, there's our side. So in list 1, I want you to put in the net winnings for each of our roles. Whoops. Don't use the subtraction key, use this sign key. -2 for that one, -2 for our second for rolling a 2. We have a net of $2 earned for rolling a 3, -2 for rolling a 4, -2 for rolling a 5, and a net of $5 if we roll a 6. Okay, and now in list 2, we're going to put the probability of each of those outcomes, which is 1/6. Whoops. Just kidding. 1/6. Whoops. Come on. There we go. 1/6, 1/6. So that's what your table should look like. Again, first you have to find out the net earnings or winnings for each of your outcomes. Then write down the probabilities for each of those outcomes to happen. And now we compute the expected value just like we did before for finding the mean of a probability distribution. Okay, so we quit out of this, go to stat and calc, enter on one variable stats, use list 1 as our regular list, list 2 will be our frequency list, and then we go to calculate. And so now our expected value is this X bar, is our average. So -1, or yeah, minus 16.7 cents, essentially. Good. So our expected value, draw, touch, is -0.167-ish. Okay. Which means if we were to interpret that, what does that mean? If we play this game long enough, we would expect to lose about 17 cents per game. Okay. If you were really lucky and you had a 6 streak rolling the die, maybe you win big. But you only win big if you stop right there, right? If you play long enough, you'll always end up at this average per game. Okay. So this game, we're going to expect to lose money. Okay. All right. So with that expected value problem down, now you're ready to go work with your group, do some other examples. And then on your online homework, you'll have a few more of these expected value problems. Just remember, in your list 1, you're going to put the net earnings or winnings for whatever the scenario is. Does that make sense? All right, go to it. Have fun.